Hello all, welcome to SKsAcademy. This is Sairaj. So today our topic is logic gates. So this is very useful for JEE Mains, EAPCET and NEET point of view. Okay na? Every exam point of view, one question is expecting from logic gates. Okay na? So we have different types of the logic gates and let us discuss about that. Okay. So now first of all, what is logic gate? Okay na? So logic gate is a connection established between the inputs and output some logic. Okay na? So suppose example, we have this is one electronic circuit. Okay na? So two are the inputs. Okay na? See, two are the inputs, one is output. It is a one electronic circuit, logical connection established between the inputs and output. Okay na? This is called as logic gate. Okay. So we have logic gates are basically not and or these three are the basic logic gates. These three are the basic logic gates. Now NAND and NOR, these two are called as universal logic gates. These two are called as universal logic gates. So okay, first of all, in logic gates we discuss about the what is in system understand only binary language. System understand only binary language. So binary language we have only two options is there, either 0 or 1, either 0 or 1. So 0 means off condition, 1 means on condition. 0 means off condition, 1 means off condition. Like switch off, on means switch on condition. Okay na? So in analog we have suppose applying 3.3 voltage, 5 voltage, 6 voltage, these are all different. But in digital binary system understand only either 0 or 1, only two options are there. So we have different types of the state codes are there. One high, this is also known as up, and closed switch closed option is there, and this is excited state and true option, and pulse generation, on condition, S. These are the state code 1. We have different types of the names are there. Same like in 0, low state, down, open switch, unexcited state, and false condition, no pulse generating, off condition, and no. So these are the different types of the state code names we have. According to the application we change the names. Okay na? So but finally we remember the only two options. So one is on condition, 0 is off condition. Okay na? So now let's discuss about the first of all NOT gate. Okay na? So it is an electronic circuit na. So here only NOT gate is the one input and one output. So NOT gate is one input, one output, one input and one output. Okay na? So A is the input, Y is the output. It is the logical connection between the input and output. Okay na? So one input A, one output Y. Okay, let's see. So here first of all this is the logic symbol of the NOT gate. Logic symbol of the NOT gate. So output Y is represented by A complement. Output Y is represented by A complement. So A complement means, suppose example, I take input 0. Input 0 means off condition. Input 0 means off condition. So whatever you take the input, complement form of that input is output. Complement form of the input is output. So 0 is the input now. So let Y is equal to A bar. So 1 is the output. If 1 is the input, 0 is the output. Complement form of the input is called as NOT logic gate. Okay na? So it has only one input and one output, that is NOT gate. Okay na? So according to the electrical connections, suppose example, this is battery, we are applying some 6 volts whatever. So here is the switch A, this is bulb output Y. Okay na? So if switch open and closed, according to that bulb will be glow. Suppose if switch A is open condition, if switch A is open condition. Switch A is open means the bulb will be glow, because here switch 2 is open. Whatever you are apply 6 voltage that going to into the bulb automatically. So this will be, this connection is open. This connection open. So if A is equal to 0, output will be 1. If suppose example, if switch A is closed, switch A is closed means automatically there is no connection establishment between the 6 volts battery and bulb, because the switch will be closed. Okay, so that's why if A is equal to 1, output bulb glowing, Y is equal to 0. Okay na? So if 0, output Y, 1, output 0. So this is about the NOT gate. Only one input, one output. Okay na? So let's see another one more, OR gate. Okay na? So clear. First of all, OR means simply addition. OR means simply addition. Okay, so here what is addition? Addition is the in between those two inputs. Addition, Y is equal to A plus B. Y is equal to A plus B. It is the inputs, two inputs. Previously NOT gate is only one input, one output, but here OR gate is the two inputs and one output. Okay na? The interrelationship between the two inputs are addition. Simply we take OR. Okay na? So A and B are the inputs and output Y. So this is the OR logic symbol. OR logic symbol, two inputs, one output, but same. Come to the truth table. So if truth table, remember the point. Truth table, not remember like this 0 0 0 0 1 0. Okay na? So remember the note point. If two inputs are, if any one input is, if any one input is high, automatically output will be high. Any one input is high, output will be high. Remaining cases, output will be high. Remaining cases, output will be 0. Only if, which case, if any one input is high, output will be high. Remaining any case means, suppose example. So according to truth table, if 0 0 means both inputs are low. If possible, if any one input is high, but here both inputs are low, output will be 0. Okay na? If 0 1, one input is high, okay, so automatically output is 1. If 1 0 1 1 1, if one input is high, two inputs high, there is no problem. So automatically this is also high. So simply OR gate is nothing but if any one input is high or on, automatically output will be on. That is Y is equal to A plus B. This is the symbolic representation of the OR gate and truth table. Remember what? If any one input is high, only output is high. Remaining only 1 and 1 case, that's it. 0 and 0 case, that is only 1. Okay na? So now same electrical, according to electrical conduction. So here A input and B input, same bulb glowing. I am applying 6 voltages here. Same. See, if 0 0 0 0, suppose A is 0, B is 0. A is 0, B is 0. So both switches are open. There is no connection established between the input 6 voltage and bulb. Clear na? So automatically bulb not glowing. 0. Next, if input is 0 and 1 combination, ante A is 1, B is 0. Whatever, otherwise if A is 1, B is 0, there is no possibility. Okay? So both are same possibilities. A is 0, B is 1, or A is 1, B is 0. Any one is on condition. Suppose first see, if A is 0, B is 1. A is 0 means off condition. B is 1 means on condition. Same. The connection is established like this. Okay, na? Automatically bulb will be glowing. Same. Suppose example, if A is 1, B is 0. The connection is same like established like this. Here also bulb will be glow. So output is these two cases, output will be 1. So one more. If both are 1, 1. If both are 1, 1. If both are 1, 1 means, so both switches are on condition. Both switches are on condition. So bulb will be glowing. There is no connection. The connection established between the input and on through two switches. So that is also output 1. Simply Y is equal to what? A plus B. A plus B. This is the R representation. Y is equal to A plus B. Simply this is addition. Remember that. So what is the logic? If any one input is on or any one switch is on, automatically output will be high. That is simply about the R logic gate. So now let's discuss about AND. Okay. So AND gate. Same AND gate is also 2 inputs, 1 output. AND gate is also 2 input, 1 output. Clear? Okay. So same. A, B are the inputs, Y is the output. A, B are the input, so Y is the output. Same. Y is equal to A into B. This is the relationship between the input and output. Y is equal to A, B. Okay. Say, see, truth table. If remember the point. So previously R logic gate is if any one input is on, automatically output will be on. But here AND gate is nothing but multiplication simply. Okay, na? So if 2 inputs are high, output will be high. If two inputs must be high. 2 inputs must be high. Automatically output will be high. So if two switches or 2 inputs are high, only at that case only output will be on. Remaining cases output will be 0. Simply see. If 0, 0 case, both are off condition. There is no connection. So simply 0. If this is off, this is on. But here condition is what? 2 inputs are on. There is no possibility. Here also 0. 1, 0, same 0. But only one and only option 1, 1. Output will be 1. If 2 inputs are on at the time only, output will be on. So this is about the AND gate. Same see. AND gate again electrical connections. Okay, na? So previously in R gate 2 switches are connected in which connection? Parallel connection. But in 2 switches are connected in series connection A and B. Okay, na? So same. Check once. If 0, 0 case, if A is 0, B is 0, both switches are open. Okay, both switches are open. There is no connection between input and bulb. Okay, so now, so automatically output will be 0. Next, if 0, 1 connection, 0, 1 means if A is 0, B is 1. This is off condition and B is on condition. There is no connection established. This is no power supplying in between switch A because there is no connection established between same input and bulb. So automatically output will be same like 0. Next 1, 0. 1, 0 case is also same. If A is on but B is off condition. Same here. This is also off condition. There is no connection established. Okay. Next last and if both inputs are 1 and 1. So here both are on. Both are on condition. Same connection 6 volts is applied to bulb. At the time only AND gate both inputs are 1. Output will be 1. So this is about the AND logic gate. Y is equal to A into B. Y is equal to A into B. This is about the AND logic gate. Okay, na? So now simply in 3 gates in simple representation. Okay, so now first of all OR operation, AND operation and NOT operation. So A, B are the inputs. Okay na, R and having A and B, two are the inputs, but not having only one input. Okay na, here A, R and R, two inputs are there, but not only one input. So OR operation is represented by plus symbol addition, and represent multiplication. Okay, now NOT operation is represented by complement over the bar. So y is equal to a bar, y is equal to a bar. So here Boolean expression y is equal to a plus b, here y is equal to a into b, this one y is equal to a bar. So remember the R and NOT in one single representation. R means addition, AND means multiplication, NOT means complement formation. Okay na, simply this is NAND and NOT and OR. These are all the 3 basic logic gates. Okay, so now let's discuss about some examples. Okay na, so first one, question number 1. So to get an output 1 from the circuit shown in the below figure, the inputs must be, okay na, so some circuit is given. So output is what? Output is 1. So output 1 కావాలంటే ఇన్పుట్స్ అనేటివి ఏం ఎక్స్పెక్ట్ చేద్దామని క్వశ్చన్ ఇచ్చాడు. ఓకేనా, సో అవుట్పుట్ 1. సో ఫస్ట్ ఆఫ్ ఆల్ దిస్ ఇస్ విచ్ గేట్? దిస్ ఇస్ AND గేట్. ఓకేనా, రిమెంబర్ దిస్ వన్ ఇస్ OR గేట్. సో హియర్ డైరెక్ట్లీ C is applied to the AND gate. Okay, so first of all output 1, this AND gate output 1 కావాలంటే must be both inputs are 1 and 1. yes or no? Output 1 కావాలంటే must be inputs అనేది both are ones. Clear? So clear. Next here R output is 1, OR gate output is 1. So OR gate output is 1. What options are? First of all C. If C option must be compulsory 1, remember C option must be 1. So first according to the option, C options 2, C is 1 1, C is 0 0. So these two are not possible. Simply eliminate that. Now OR gate output is 1. So OR gate output is 1. We have two possibilities is there, A0 B1 or A1 B0. We have two possible. Check 0 1 combination is there and 1 0 combination is there. See na, 0 1 combination is there and 1 0 combination is there. Okay na, same according to the example. So options A is 0 0. If A 0 0 means OR gate is 1, no, so that's why eliminate the option A also. Now A is 1, B is 0 and C is 1. So option C is correct. Option C is correct. Okay, clear? So first of all remember the మనకి ఇక్కడ ఏ లాజిక్ గేట్ ఇచ్చిండు, remember the logic truth table. Okay na, so that's it. Now one more example. So here waveforms is given. The given figure shows the waveform for the two inputs A and B, and that for the output Y of a logic circuit. The logic circuit is, okay na, so adi edi AND OR NOT whatever, check it. So first of all we have inputs A and B are the inputs, Y is the output. Let's see. If 0 0 possibilities, first of all check it. If according to the manak pulse sigma, pulse is 0 and 1, two combinations here. If pulse is low means this is 1 0, this is 1. We have two combinations. So let's check it. This is 0 0, output is also 0. Next this one 0 1 0. Clear? Next 1 0 0. One more 1 1 1. One more 0 0 0. So output 1 when both inputs are 1, output 1 when both inputs are 1, output will be 1. Remaining A cases output will be 0. So it is which connection? It is a AND is a, if two inputs are on, automatically output will be on. That is AND gate. Option A is the correct. Okay na? Now one more. So if A B C D are the inputs, A B C D are the inputs to a gate and X is the output, then as per the following time graph the gate is same. Sir, actually previously AND or that is only 2 inputs 1 output, but here how many inputs are there? 4 inputs are there. So don't confuse, whatever manaki enni inputs ichina gaani just remember the logic. Okay na? So first see same time graph, we have different time graphs, and let's check it. Okay, so first of all 0 0 0 0, so output is also 0. One more 1 0 0 0, output is 1. So one more 0 1 0 0 0, sorry 1 here. So this is 1. 1. Now 1 1 0 0 1, one more 0 0 1 0 1, one more 1 0 1 1, and one more 0, output is 1. So if only possibility is if all inputs are 0, at the time only output will be 0. If any one input, first case if A is 1, in second case B is 1, in third case D and C also. Okay, so whatever, if all inputs are 0, at the time only output is 0. Remaining any one input is on, automatically output will be 1. So this is for which gate? OR gate. OR gate means if any one input is on, automatically output will be on. Okay na? So whatever the inputs ఏమైనా ఇవ్వని, but check it if the remember the logic. Okay na? So OR gate is if any one input is on, automatically output will be on. So that's why option A is the correct. Okay, so now one more. Okay, so this is are the 3 examples of based on the AND, OR and NOT gates. Okay na? So thank you.